All right. Well, good morning, Steve. So far, this is a session of one. So you get the. Oh, here comes one more. So I'm Gary Myers. I'm our director for outreach for Vernier, and Dave Carter is our STEM training director. He's going to lead the session today. I'm just going to be keeping an eye on chat and letting people in. Dave.
So like Gary said, I'm David Carter and STEM training director. And my background, I'm a physics guy by trade. I used to run the instructional physics labs at the University of Mississippi. So I've been using Vernier products in one way or the other for the last 31 years or so. So today's session is about our Vernier video analysis. And it's a tool that allows you or your students to analyze motion via video. And it's based on a tool that we've had for several years. We started when we had this tool under our Logger Pro software. But over time, as things have evolved, we needed a version of this that could run on multiple platforms and not be an actual software base that has to be installed on a machine. And that's where the Vernier video analysis, where it's come from and where it got its start. So the deal with the video analysis is that it's a web app. And it's designed to run on 5 different platforms. So, basically you need a modern browser to make it work. So it really runs under the browser. And so, you could use it. I've got it on my cell phone. I've got it on the computer, Chromebooks, Android, it doesn't matter. And so that's great because this came about because we had our video physics app that was designed for iOS devices. So things like iPads and iPhones, but everybody's like, yeah, but I've got Chromebooks and all of that. So that's where it comes from. And the real advantage of using the video app is that it allows you to make measurements of motion of things that would be very difficult otherwise. Maybe you've used a motion detector when students are walking back and forth in front of the motion detector or rolling a car down a ramp or something like that. But invariably, somebody in a workshop that I'd be doing, they would say, "Oh, I want to use, this to, drop a ball off the back of a football stadium. I've got a bowling ball. I'm going to drop it. Can I use the motion detector to do that, or set up a photo gate to be able to do that?" And it's like, yeah, no, that just doesn't work. Just because the range of the motion detector or trying to get it all right just didn't work. But the video part really works. And so that's the real power of it. And especially if you're thinking about where we are right now, is that if you're trying to do something virtual, if the students, probably a large percentage of them, have something like a cell phone or access to something like some technology that would run the app, then you can have them utilize this. So the app is it's basically a year subscription the way it's done. And so I think Gary's putting up a link to a 30-day free trial for that. So you can go through that. And but what I really want to do is basically show you how it works. And we'll go from there. So what I need to do now is I'm going to share my screen there. You know what, Gary, we might ask, I know we've got several people there. You might put this in your chat. Has anybody been using this app or used any of the video analysis apps? You might just ask you there, and we can throw that up there in the chat and see what people say about that. See, Gary's got another link there. So I'll I'm gonna go ahead and share, and we can. So I'm going to be sharing my screen here. So let me go there. There we go. So what you're seeing now is I'm in Chrome, and so I'm just showing this, the video analysis app tab. And what happens is that when you buy it, or you get the 30-day free trial, there's a code that you put in, and it allows you to access it for the period of time you've got. And as long as you don't clear the cookies within the browser, then you won't have to enter that code again until it expires. If you clear the cookies, it actually does disappear, and when you go again to use it, you have to enter it in. Now, the nice feature about that, it means that though it's a web app, it will run when you are not connected to the internet. As long as you've not cleared the cookies, it still will run within the browser itself without having to have internet access. So that's nice because you may be in a situation where you don't have internet access, but you still want to be able to use the app. So just keep that in mind. So what you're seeing here is I've got my the screen up here. And so when you launch the app there, and what I've done is I just keep it as a tab in the browser. So I can go and just open it up and it's always there. So that's a good piece of advice. Just store it as a bookmark or a tab, and so that you can open it at any time. So let's take a look at this. I'm going to show you at least one of the sample videos that's built into the app. And so we can kind of walk you through the process here. So I'm going to open up the basketball shot here. And so we'll just start with this one. And so at this point, what we have is this is one of the sample videos here. And so he's going to be throwing the basketball through the air, and we want to be able to track that motion. Again, this is an example of something that would be basically impossible to do with a motion detector, just because it's a two-dimensional projectile motion, and it's a fairly big object. And so it's impractical to do it any other ways here. So if we come here, I will just do this. I'm just going to play the video. And so there we go. And then I can come here, and maybe I even do this. I'm going to grab the little tab here and make it bigger so you can adjust the different sizes of what's on the screen here. So one thing to do is that when you're doing the actual analysis of the video, it's best to make sure that the video screen portion is as big as it can be, so that it allows you a little bit more precision there. But I can scroll over here, and then if you'll notice, you've got a data table and you've got graphs there. So that's what that's all about. So let me go over this way. Let me rewind. And so what we want to do is I want to follow the motion of the ball when it's going through the air. I want it to follow it after it's left his hands, and we follow it through that arc there. Now I can do this. If I go down to the left-hand side there, I can grab the tabs and move it around if I want to. And so, the part of the motion I really want to analyze is maybe from here. And then, if I maybe move the tab all the way over to here, maybe I want to stop at the bounce. I mean, I guess I could go beyond the bounce, but we can just follow that. Now, so if I do the replay, so if I rewind and go back, it starts all the way back. One of the things that I can do with this, if I do scroll forward until we just see this piece, I can grab the little arrow there, and what that will do is it doesn't really crop the video. It just crops how far back it goes. And this is convenient because if you've done your own video, your students have done your own video, maybe they shoot 2 minutes of video before the actual action occurs that they want to analyze. And so that way they can basically ignore that if they didn't really crop the video themselves before they imported it, so that they can kind of crop it on either end, just so that they're doing the analysis they want to do there. So let me back it up just a hair. I want to get it because it's just left his hand there. And then what I want to do here is I've got it marked with add point. And so I want to start tracking the motion of the ball. And so you'll notice I have little crosshairs there. And if I'm going to put it on the center of the ball, and if I click, and so what I'm trying to do is click there. My internet may be giving me a little trouble here. So said it was unstable. So I don't know if I'm blinking out there or not, but so
Just
let
a
me
little
come.
hesitation in your audio, but it's working
Yeah,
well now.
okay. Okay, good. So I've warned my family to stay off the internet, but whether or not they did or not, we'll see. Um, so anyway, so I'm marking basically every point right now. Now, one of the things that I can do here is that I could mark every point. If I don't want to do that, if I come down here to the settings on the lower right, I can have it where it advances the frame by more frames. When I click one point, it right now it's doing one frame. Leave that that setting the same for my own video. Show you how to do it, and I know I'm going to want to be able to do more frames there. But so I'm just gonna I won't change that. But what I'm going to do instead is I'm going to use the track function, and so the track function is kind of interesting, is because instead of me having to click on the object, in this case that ball, and following it across the screen, the app itself will do this. Now the key part of this is that for it to track the object itself is that the video in the background, there has to be a a fair difference in the background. You'll notice that we're using a basketball over the top of a white wall. So the difference between what the foreground, the object looks like, and the background is key. If I were throwing this basketball across an orange wall that matched it, it wouldn't be able to track it because it's looking at that difference in what the actual background looks like to be able to do that. So keep that in mind if you're trying to do this yourself. So what I want to do is I want to do the auto tracking. I'm going to come here, and this little tool, the little slider, allows me to kind of adjust what it's tracking. So really what it's trying to do here is I'm going to kind of shrink it down so that it is just going to track the ball so that it sees that against the background, and we can do that. And so if I do start auto tracking, I can just sit back and let it go. And then we get that part. So and it actually loses the track there because of the bounce. But one of the things that the app does is that it uses a little bit of prediction. It knows something about physics. It assumes that we're doing this motion on Earth. So it knows kind of where the object probably should be based on what we know about that. So that's part of it. And so after the bounce, it loses it. I could kind of continue on and keep tracking it and have it keep going, but we'll just stop with that for now. So now we've got the object tracked, and let's take a look. I'm going to slide over here, and let's take a look at the graph here. And if I look at just the graph, what I end up with, it says X and Y is a function of time. Now, if you look at the axis here, you'll notice there's no scaling. So it knows nothing. And in fact, what it's using for scaling, that's actually pixel number. So it's actually tracking where it is on the screen just based on pixel. So it doesn't know anything about the size of the background. Now we've put something in the video that establishes the background size. And from that, we can actually scale it. And that's what I need to do next, is scale it so that we can track that. But the key point of that is that the motion could be something very tiny. I mean, maybe I'm doing a video of something in a microscope. I want to, I've got some, little paramecium moving around, and I want to know how fast it's going. As long as I know the scale of the background and can track the motion, I can do it. And so that's what's key here. So let me do this. I'll slide it back over here. And again, I want to do this so that I'm making the video as big as possible, because what I need to do now is, let me turn track off, is I need to, I go to system, and this allows me to do a couple things. One is that it allows me to set the scale. And so I get this marker, and it says, to move to something with known separation distance. Now what we've done is down here at the bottom of the screen, there is a meter stick on the ground. And so I can come here and I'm trying to set that end to end to be able to do that. And so it's saying 247 pixels is a meter. And this is the other thing that's key, is that setting the scale. If I had something that was really, really small in the screen that I was trying to do that, the error that I might have in just me trying to drag could be big. For this video, if we'd had something that was 3 meters long, it actually would be a little bit better, because I could track 3 meters and say that's 3 meters. Now, another thing about setting of the scale is you need to make sure that the scale is in the same plane as the motion. If it's not, you're going to end up with parallax error. Years ago, I was doing a workshop where people were using the tool in the other piece of software, in the Logger Pro software, but they did something where they set the scale way in the foreground when looking at something way in the background. In particular, there was a truck going past. They were trying to figure out how fast the truck was going, but they set their scale way in the foreground. And it was one of those things, as a teacher, I could see coming. I knew what they were going to do, and they were like, "Wait, this doesn't make any sense." I said, "Where's your scale?" And so they were actually able to use the truck as the scale and be able to figure that out. So that's just something to keep in mind there. So that's how we set the scale. The other thing, if I do the system, I can click here, and so we can, well, let's do the analysis first. And then, so if I go back over here. So let's see here. So we've got the graph there. You'll notice that we've got, it's in X and Y. So it's a two-dimensional projectile motion here. Now, what I can do is I can choose what I want here. Maybe what I would like to do is, what if I just have this be the in X, the velocity at X. And then I want to do another graph. If I go up to the upper right corner here and do view options, I could have two graphs. And maybe the bottom graph, I want to be just the Y velocity there. And so then I can be able to do that. And at this point, I can come in and maybe I want to know some things about this. Maybe if I come in here, I could do the analysis features are here, and so I could come in and maybe I apply a curve fit to that portion, and what's it going to give me? So if I'm looking at the slope and X versus time, well, it's going to give me the velocity in the X direction if I want to. So I could do that. Now, if I come down to this one, I've got the velocity in Y. So we could come in, and if I wanted to actually be able to do the curve fit on that one, so I go down and apply the curve fit, and then I would get the acceleration. Now my value is a little off there, and it may be because of that setting of that scale. Because remember, I didn't set it all that well there, and so that we got that one. If I wanted a so I could come in here and notice that I've got the velocity. I could come in and actually have it do a calculated column if I wanted to. So let me go up here and let's actually look at the data table. I forgot, I've got it squished over here. So let me squish it. Let me get it back here. And if we come and look at the data table, then I can come up and do this, move it around a little bit. I could come in and we can see what we can do under the data set there. And if I do a calculated column, notice that I can come in here and these are various equations that I could do. I could come in and say, hey, I'd like to do the first derivative of the position as a function of time and have it graph that. When I taught college physics, I would do some things where I would have students do a graph of position versus time, and then I asked them to do a graph of the derivative of the first position of the position versus time, and then I had them compare it to a velocity graph, and they would say, "Oh, they're the same." I was like, "Yeah, okay." So that's that relationship, and so they can come in. I could do the first derivative of the velocity, and have it be acceleration. So why don't I do that? I'm gonna come back here and let me click off of that, and I'll go here and let's do, what if I do the Y velocity and we do add calculated column. and I call it Excel, and I do meters per second squared, and I do the first derivative of that. And so now I've calculated that column. And if I wanted to actually do the graph of that, I could come down here and I could say, hey, I want the Excel versus that. And so I'm clicking on the label of the axis and turning off what I don't want displayed there. And so now I've got a graph of just the acceleration of versus time, because I calculated it there. And then maybe I run the statistics on it there and get an average value. Now, what I notice here is that these first points, I may have gotten it where the ball, if it was still not quite left his hand when I did it. And so that may be throwing it off. So one of the things I might do is come in here and say, well, let me just make sure that I'm analyzing the portion of the data when I know the ball left his hand and before it, maybe even got to the ground on the other end. And then I can come here and run the stats on that. And I get a little bit better value if I do that. So, Gary, I don't know if we have questions at this point.
No, it was just a question about the site license, and I answered that.
Okay. Okay, so let's do this. But why don't I want to show you how you would do your own. So we'll do that. So I'm going to come up here and I'm going to say new experiment. Now, the thing is you're like, well, what if my students do this? So they use the app and then they, what do they do? Well, if they come here, they can save it. And what happens is it saves it as a VMBL, which is the video file basis, and you can give it a name and store it. And that way they can open it up later. So any work that they've done inside the app and the analysis and all that still exists. So
David,
yes.
Before you close this out, we did have a question. Was the red dotted line the displacement of X?
Yes. Yeah. It's the displacement of X. So it's position across in the X direction. So that's what that is. Okay. So let me come here. I'm going to do new. I was talking about saving export. You can actually export it, the graphs individually, or even the video itself, and it saves them basically as a PNG file. So it's a picture file, and they can be able to do that. And then of course you can even change the aspect ratio and various other things. And that's so if they use the tool, they want to use it. So you're turning in a lab report or something like that. So. All that being said, I won't bother to save that. So let me do a new experiment there.
While you're doing that, the next question is: are there any specification requirements? Requirements for the videos that get uploaded into the app?
There are. I don't recall right offhand which videos formats it can handle a bunch of them, and I think it's under the. I know there's a user manual, and they'll talk about that, what kind of video files it can handle, but it's most of the ones, if you took it with your phone or whatever, it's the standard ones that would be used. So there's information that has that list, but you're pretty much assured that if you're using an iPad or your phone or a Chromebook or any of that stuff, is that whatever video style it can take, it can handle. I guess the issue is as you're trying to import some video from the internet to analyze it, you might not have the right format to be able to do that, but by and large, you probably will. So anyway, so let me do this. I want to do, since I'm going to start my own here, let's see, I'm going to do this. Well, let's see, I'm going to actually show you one that I've done first. And let's see here, plane landing VMBL. And so this is one that I've done, and I'll actually show you how I did it here in a second. So let me back this up. So this is one that I did a few years ago. I was doing some workshops in New York City, and I had checked into the hotel. It was a Hilton across the street from JFK, and I said, "Hey, I want a room facing the airport so I can, sit there and geek out all afternoon and take videos of airplanes landing and determine the landing speed here." And so that's what this one's about. So if I come here, I track the motion of a jet landing, and so we did that one here. So I'm going to do my own. I'll show you actually how I did that. So I'll do new experiment, don't save. And let me do choose file. And I want to do that one. Okay, so this is the one that I just did. So I had this video that I already had in place. I knew where it was. And so I've put it in there. And so if we just watch the video now, you're going to see that, well, there it comes. And it's off screen here. So let me do this. I can back it up here. And, like I did on the other one, right? Maybe I scroll forward here. So now I see the nose of the plane, and I might even do this. And I need to track the motion of the object. In this case, it's the plane here. So if I do add point, I can come here and I can click, and I can click, and I can click. Now, remember when I started the other session, I said that, I went ahead with the basketball shot and had it do every frame. That was fine for this one. But you'll notice I click and not a whole lot happens here. So because it's the frame rate is pretty high and the motion, I'm pretty far back. So what I might want to do here is I could come here and maybe now I do say, hey, I want to do every 10 frames. So now what will happen is when I click on the nose of the plane, it actually moves it forward by 10 frames. And so I'm not having to mark every single point. Now I have figured out also that I can do the auto track feature here because again, it's looking at the difference between the foreground and the background. There's a good differentiation between that here. And so if I actually come up here and say, hey, I'd like to track that, and then come over here and be able to do that. Get it right on the nose of the plane there. And then I'm going to leave the circle fairly large and just do start auto tracking. And it'll do that until it gets off the screen there. Now, so now I've got, again, X is position in X. Y would be the Y velocity. It's not sinking all that much. So I was kind of interested in saying, well, just, what is how fast was the jet going as it landed? Now, here's the key part. How do I determine the scale of the background? Or how do I determine the scale? Well, I can use the jet itself. And so that happens to be an A380, Airbus A380. If you've never seen one, they are huge. It's that great big double-decker plane here. So what I want to do is I'm going to, let me back it up here and let me see, I'm going to do my system here. And I'm going to back it up, the video. Let me rewind the video there. Here we go. And I'm going to get it to where it's here. And I can come here and I'm going to use the tip to tail and be able to do that. Now, I knew what kind of plane it was, and so I looked up the length. It happens to be 79 meters long. And so now if I do that, then my graph over here is now scaled in terms of meters. And so I can come over here. Maybe what I'm really interested in is I want to know the X direction or the velocity there. And so I'm going to come here and just display position as a function of time. And then the slope of that would give me the velocity there. And so let me apply a curve fit and apply, and I end up with right at 79 meters per second on landing. And as I recall, I looked that up just to know, it was a published value, and so I could figure out how close was I? And when I did the value, I was just slightly above the posted landing speed, which makes sense because it has not landed yet. So it's still, it's slowing down, but it's still, it's still moving. So, but the use case here is that there was no way I could use a motion detector or a photo gate to determine that real world motion. So are there questions about how one would do that there?
No, we've got a couple of comments about one person says this looks like this would be really helpful for middle school math and graphing students.
Oh,
Says
sure.
I'll share, yeah, middle school math teachers they're going to share information with their middle school math teachers.
Awesome. Yeah, and it's interesting because over the years I've done lots and lots of workshops, and sometimes people are like, well, it's all science. You don't have anything for math. I'm like, well, once we generate the data, it's all math from there. So being able to, go through and do the analysis there.
Right.
Yeah. So anyway, let me show you that one there. Other things that we can do here. Notice you can turn the trails off or on. You can track different objects if you want to. So I could, maybe if I had multiple objects going through the screen, I could actually track another object. Maybe if I wanted to do add a new object, I could do it where I am, maybe what I'm doing is tracking. If I come up here and add points, maybe I track the tail as a separate object here. So if I come here and add let me turn track off, add point. Now, if I track this, it's doing it as a separate object. And so I could track another object. Maybe if I'd done the video long enough, one plane lands and another plane lands, or you're looking at motion on a highway and you've got cars going past, multiple cars going past, and you want to use different objects there to be able to do that. You can do that. Tell you what, let me do this one. I'm going to go back and reopen the basketball shot we had there. And I'm going to quickly, I'll go back and I'm going to track and get the data again really quickly. One thing I didn't show you here is one thing that was added fairly recently was the ability to put in the vectors if you want to. Of course, this will also show you just how quickly you can do this, because if I've got the motion, if I know how to do it, I can come in here and in a matter of seconds, I can be able to have that scale the way it needs to be. And so that's a meter. Whoops, you know what? Maybe I needed to, oh, that's weird. Let's scale. So let me come in here and a couple things I can do. The origin. I didn't do this before, but you can actually move where you want the origin to be. So maybe if I wanted the origin to be, the instant the ball left his hand, I could come up here and slide over just a hair. Go back a frame there. There we go. But maybe I put the origin there. And so now if you'll notice, it changes the graph as I move the origin around. So I could say, hey, I want the origin there, or you could have the origin, down at his feet. So you set it to where the ball bounces. So you're starting from the height above the ground. So you come back down here. So you might want to do that. The other thing you can do is if you want to, you can actually rotate the axis. So depending on what's happening with the motion, you can do that. And I've had instances where, the video that I took was, on a slight angle. And just because I messed up the video, I'm like, well, okay, I can straighten the world by changing the axis there. and being able to do that. So you can rotate the frames there. Other things, let's see here, if I come here with the, back to edit there, and let's see, system. So we've got that one. Let's see, what do I do here? You got different coordinates if you want to. So polar coordinates, if you have something that you've got rotational motion, you can do that one. Let's see here. I wanted to, what did I do with my vectors there? Let me turn that part off. So are there questions? I know we're actually getting close to.
No questions. Yeah, we've got about 7 more minutes.
Okay. So let me turn the system off there.
But feel free, if you have a question, if you want to type it into the chat, you can do that. Or if you just want to unmute yourself, there's only a handful of people here, so it won't be disruptive if anybody wants to ask a question. Are there system requirements for running this program? Would it work on school issued Chromebooks?
Yes, it will. So again, the app, it's web-based, and in fact, it runs best on Chrome. So that's going to be the default browser on your Chromebooks. And so the fact that it's web-based and runs in the browser, I mean, I guess if you had a really old Chromebook that maybe doesn't allow it to update to the most recent versions of the Chrome OS, that might be an issue. But in general, that's, they will run if it will run the most recent version of the browser, unless it's a really, really old Chromebook, you should be able to do that.
Cool. There's another question. For data analysis, is there a menu of common formulas embedded in the app that can take the data and compute specific values, e.g. momentum or standard deviation?
Well, what you could do, momentum, yes, standard deviation, no. But when you do the, if I go to the data, so I've got the data table there. Let me scroll up here. Okay, get the data table, be bigger. So to do, those are calculated columns. So if you wanted to do something like momentum, you could come in here and you could say, hey, well, if I wanted to do momentum, I guess I need to do from the, do the velocity column here. So if I came in there in velocity and said, hey, I want to add calculated column, and I said momentum, and I do insert expression. So I want to do velocity times mass. So I just need to come in here and I've got, what I would use is this formula, A times X plus B. So I could, the A term could be the mass of the object. So if you knew that, you could insert that. And then X, in this case, it would be the velocity. So I could put in that parameter. And then B is just, well, it's 0 for this equation. So you could have it calculate the momentum and be able to do that. Speaking of that, let's see here, if I go back, let me see, let me do this one again. Let's see, I'm going to take a look at.
Well, there's another, what will the data and graphs look like if you export them out of the app? What are the export file type options?
Okay, so let's, we go back to this part there. So again, the export function here is, here we go. So what's happening here, notice it says, I want to export the graph, and the file type is PNG, which is a photograph. So it could be printed, from anything. And so that way you're taking that out there. And so if I want to export that, if I want to export the video, I mean, it actually does save it in a format that's that way. So you can take the whole thing out there. But it's essentially a picture of what all's been done there. So if you've got the analysis there, you could have that. And then you can change, the line shading, whatever needs to happen there. Do you want the axis to be labeled and all of that? And then again, that ratio there. Now, That's
Can you
if you
export
are
the data?
exporting it. What's that?
I say, can you export the data also separate from
Well,
the
what
images?
you're doing there is if you do, let's see here. Oh, let me do that. If I do save, what you're doing is you're saving the as a VMBL file. I don't think currently, if you are doing, let me see, if I go to the data table and I do export, let me see here. No, it's still actually doing it, yeah, because it's not taking that data out. I'm trying to remember if you can, in the olden days when we did this, we would always have to use graphical analysis there. So let me see here, can we do that? Let's see, if I rename the data set.
Can you copy and paste the data?
Yeah, we can do that. So we can copy and paste the data into graphical analysis if we wanted to, which is a free app. And so you could have that where you can copy and paste it. I thought, let's see, I'm trying to remember. I've never actually exported the data because I use the fact that the analysis is inside the app. I don't have to because it already has all of the analysis features that I wanted there. So I haven't taken it out there. So, but I think right now that it stays in there. So unless you just copy and paste it, but you could copy and paste it into Excel if you wanted to.
Great.
So now we have just a couple of minutes left there. Let's see if we do the other questions.
No other questions at this time. I think that's about it.
Okay. So I would encourage you to download it for yourself. You can get that 30-day free trial and try it out. One of the things that I didn't show is that under the three little dots in the upper right corner is distribute app. And so what happens is because if you buy it, it's a site license for you and your school, is that when you do distribute, it gives you a code that you share with the students, and then they can open the app and be able to use it. So that's how that works. And so that's how you end up distributing. And of course, there is a user manual there and other things. And it talks about what's new in the app, what was added here. So different formats of video. People have asked about which kind of video, but that's something that's always ongoing. So the app will be updated constantly. New features are being added. In fact, the Cartesian coordinates was added fairly recently to be able to do that. Well, let's see. I'm going to stop sharing that. And we appreciate you guys coming. Download it, give it a try. And so I know you're giving up your Sunday morning or wherever you are, whatever time of day it is, to join us. So hopefully you found it useful.
All right. Thank you, everyone. We got some good feedback, so we really appreciate it. Take care.
Great. You guys take care. Bye-bye.